Hi, welcome to Module 2, Section 3 of the POW Instruction course for Science. This whole section is about the three dimensions of the framework, and this video is Part 1, the disciplinary core ideas. Our goals for this section are to articulate the organization and content of the disciplinary core ideas, and we want to be prepared to make alignment judgments and participate in the consensus rounds. Also, we want to identify ways in which the material in the framework relates to the current content of our science instruction. There are two resources for this section. One is a PDF or hard copy of the framework. The other is the POW Instruction Science Reference Disciplinary Core Ideas document. If you haven't downloaded these yet, please take a few minutes to do so. You'll want to have the PDF or hard copy of the framework available when you do your alignment. The DCI reference document I recommend you actually have out in front of you during this video. This would be a great time to pause so that you can either print a copy or locate your copy if it's just not right in front of you. So this section will go over the broad outline of the DCIs included in the framework. We'll go over the basic questions of each of the core ideas themselves. In your alignment, you're going to go all the way to the component level of detail, and our goal in this video is to give you the broad overview that you need so you'll be able to navigate the framework and reference document to learn more about component DCIs when you get to the point of alignment. As we went over in Section 1, one of the guiding principles of the framework was to limit the topics covered to core ideas and principles. This is important because it allows us to go to greater depths about these topics, which gives students a better foundation for life. One of my favorite quotes from the framework is, "An important role of science education is not to teach all the facts, but rather to prepare students with sufficient core knowledge so they can later acquire additional information on their own." At the end of this presentation, we will go over the 4 criteria that the authors used to determine whether or not things would be included, pieces of content would be included as DCIs. But for now, we're just going to present what is included, and then we can talk about how those decisions were made after. The disciplinary core ideas are broadly grouped into 3 major categories: life sciences, physical sciences, and earth and space sciences, which are the traditional groupings for science content. Physical sciences is divided up into 4 core ideas, and as I mentioned before, each of those is further divided into component ideas. In your alignment, you will look at both the large core idea categories and try to isolate a single component idea. For this video, we're only going to go into depth about the core ideas, and then you'll be able to use the reference documents, the framework, and the PDF that you've downloaded to go into more detail. You can see here and in the reference document, I've listed the page numbers in the framework so that you can easily find those relevant sections. And we'll walk through one example of how you would use these documents for alignment, but we're not going to go through all of them to that level of detail. For each core idea, there is an overarching question. Individual component topics have their own questions, which you can read in the framework. Here are the 4 overarching questions for the core ideas in physical science. As we go over these questions, you might want to make notes on your reference document about where this fits in your curriculum or which topics you might cover that fit here. As teachers, we spend a lot more time interacting with our materials and our curriculum as we do our planning than we do with individual standards. And so taking some time to connect the dots between what you plan for your classroom and what the sections of the framework say might make the alignment process a lot more meaningful and help you to make those connections back to your own classroom. So the first core idea is matter and its interactions. And the overarching question for this core idea is, how can we explain the structures, properties, and interactions of matter? The second core idea, PS2, is motion and stability, forces and interactions. The overarching question for this core idea is, how can one explain and predict interactions between objects and within systems of objects? The third core idea is energy. The overarching question for this core idea is, how is energy transferred and conserved? And the fourth core idea is waves and their applications to technologies for information transfer. The overarching question for this core idea is, how are waves used to transfer energy and information? So in order to help you become more familiar with the reference document, I want to show you just one page of the document here and do a quick walkthrough of how you might use it. So let's say you're doing a unit that asks students to think about Newton's laws. In this unit, you may be looking just at forces. You might also be looking at energy. It would really depend on which laws you're covering and how deep you're planning to go. The two questions you might be looking at would be PS2, motion and stability. How can we predict and explain interactions between objects and within systems of objects? And PS3, energy, how is energy transferred and conserved? And really, again, it would be a question of what you were doing to determine which one of those questions you'd be in. So what you see on the screen is the layout of the reference document. This is taken directly out of the appendix to the Next Generation Science Standards, and while we're not aligning directly to the NGSS, the feedback from the initial participants in this workshop was that this was a really useful tool for alignment. The matrix provides some basic statements about content that would be covered at different grade bands for each of the component core ideas. So let's kind of zoom in on the elementary statements for PS2 and the relevant section of PS3 for our sample topic of Newton's laws. I can use these statements for my alignment. I can also use these statements to go directly to the framework and look at what the author said. For example, here, PS2A and B are combined. This indicates that at the elementary level, we aren't making a big distinction between forces in motion and the interactions themselves. It won't be until later that there's a strong line drawn between these two. If I want to understand more about this, I can read about PS2A on pages 114 to 116 and PS2B on pages 116 to 118. I'll need to pick one of the two component DCIs to use for my final alignment. In my comments, I might explain why I selected one over the other, given that they were combined. And I might also comment on how comfortable I'd be swapping one for the other. For example, if my unit on Newton's laws is actually talking about more about pushing harder versus softer, I'd probably pick PS2A. But if my pushes were going to be different types of pushes, and I was actually going to use some contact and some non-contact forces, I definitely would want to do PS2B. So I'd want to be really thoughtful about which direction I was headed, even in a case where I see that within NGSS they're not making a large distinction. So that was kind of a walkthrough of how you might use this document. We're only going to do that one walkthrough. The document is really consistent in terms of the structure across different grade levels and different subject areas. And in your reference document, you always have the exact page numbers, not just for the bigger core ideas, but also for the individual component ideas. So life sciences is our next big category, and it's divided into 4 core ideas. I've again listed the page numbers in the framework for each of those DCIs. The 4 questions, again, we'll go over those, and again, you would probably want to take notes so that you can think about how this fits into your curriculum if you cover topics in the life sciences area. Our first core idea is from molecules to organisms, structures and processes. The overarching question for this core idea is how do organisms live, grow, respond to their environment, and reproduce? The second core idea is ecosystems, interactions, energy, and dynamics. The overarching question here is how and why do organisms interact with their environment, and what are the effects of those interactions? The third core idea is heredity, inheritance, and variation of traits. The overarching question is, how are characteristics of one generation passed on to the next? How can individuals of the same species and even siblings have different characteristics? And the fourth core idea is biological evolution, unity, and diversity. The overarching question for this core idea is how can there be so many similarities among organisms, yet so many different kinds of plants and animals and microorganisms, and how does biodiversity affect humans? Earth and space science is our last category, and it's divided into 3 core ideas. I've again listed the page numbers in the framework and for each DCI. And here are the overarching questions for the 3 Earth and Space Science core ideas. Again, you might want to take notes on your reference document. The first core idea is Earth's place in the universe. And the overarching question is, what is the universe and what is the Earth's place in it? The second core idea is Earth systems. The overarching question here is, how and why is Earth constantly changing? And the final core idea is Earth and human activity, where we think about how Earth's surface processes and human activities affect each other. As teachers interact with the framework, a common topic of discussion is why some things have been included and highlighted and others are not specifically mentioned. The authors created and articulated key criteria for inclusion in the framework. They required each DCI to meet at least 2 of these criteria, and they preferred that the DCIs would meet 3 or 4. The 4 criteria were that a DCI must have broad importance across multiple sciences or engineering disciplines or be a key organizing principle of a single discipline. It needed to provide a key tool for understanding or investigating more complex ideas and solving problems. Needed to relate to the interests and life experiences of students or be connected to societal or personal concerns that require scientific or technological knowledge. And finally, it needed to be teachable and learnable over multiple grades at increasing levels of depth and sophistication. That is, the idea can be made accessible to younger students, but is broad enough to sustain continued investigation over the years. As you come across items that spark questions in you, either about inclusion or exclusion, I encourage you to return to these criteria to think about what the logic of the authors might have been. This is another one of my favorite quotes from the framework. An education focused on a limited sets of ideas and practices should enable students to continue their development well beyond their K-12 school years as science learners, users of scientific knowledge, and perhaps also as producers of such knowledge. We need to be really sure that we're less focused on checking off content and more focused on preparing students for this vision of lifelong learning.